That's good. That's good. All right. You guys got some questions or whatnots here? Oops. Yeah, Joe?
Can you explain how to solve 3 and 4, or just one of them, whatever one?
Sure. So all I'm going to do is I'm looking at the degree of the polynomial is going to tell me all the information I need.
Okay.
So if I'm doing 3, what's the degree for the polynomial?
Or if you're doing number 3?
Yeah.
5.
5. So that tells me this could have at most 5 zeros.
Okay.
And it could have at most 4 extrema.
Isn't it always 4 extrema for polynomials?
It's going to be 1 less than the degree.
Oh, it's 1 less than the degree.
Yep.
Oh, okay.
So remember, at most is an inequality, though. So at most means like 5, 4, 3, 2, 1, or no zeros.
Okay.
And at most 4 extrema means could have 4, 3, 2, 1, or no extrema. So just keep that in mind, that those are at most 5 and at most 4.
Okay.
But there's nothing really to do. There's no calculation to be done. You're just using a theorem and reading the degree from the formula.
So is number 4 9 zeros and 4 extrema?
Would be 9 zeros and 8 extrema.
Oh, 8 extrema. Oh.
Yeah, always 1 less than the degree.
Okay.
And again, you'd need to say the word at most in front of each of those.
Okay.
Because it's not exactly 9 and not exactly 8.
Okay.
It's at most. We don't know for sure, but that's the most it could be. Leo?
I'm sorry, I wasn't listening that much, but negative doesn't affect the 5, right? If there's still a 5, it's
So it's the leading coefficient does not matter. It's the degree.
Yeah, I know. I'm talking about, okay.
So there is no, the negative 5 is a coefficient. The degrees are coming from the exponent. So the negative 5 does not matter to us when we're talking about whether the number of zeros or the number of extrema.
Okay, yeah, so 5 extrema.
No.
Oh, okay.
Oh, for number 3?
4.
Number 4, there would be 9 zeros and 8 extrema.
Okay.
1 less than the degree.
Okay.
The leading coefficient does not matter.
I see. Yeah, I was just trying to. I see.
Okay? Is that okay?
Took me some moments.
You're there, though.
Now I am, yeah.
Okay. Grace.
Can you do number 5?
Sure. So immediately for 5 through 8, I notice that all of these are polynomials, correct? So I know that polynomials just have 2 end behaviors. They have an arrow at the left end and an arrow at the right end. So immediately I can write this part.
So it's always negative and positive.
Yep. And all I need to do now is look at the graph and see if the arrow at the left end is pointing up or down, and if the arrow at the right end is pointing up or down. So I'm just going to type in the equation into my calculator. Oops. After I put it back into a different mode. So what do we got here? Negative 4x to the 6th. Boogers. Minus 7x squared plus 5x minus 6. And I don't know what I did last time, so I'm just going to hit zoom standard because I don't know what my window looked like before. So here's my graph. I can see it a little bit. I probably want to rearrange this a little bit so I get a better picture. So maybe I'll go make that y min negative 100 so I can get a better picture of what's going on there. That should be good enough for me, though. I notice that both ends are pointing down. So left end points down, so it points towards negative infinity, and the right end is also pointing down, so also towards positive infinity. So again, the way I read this is this part just says left end, that says right end, or right arrow and left arrow, whatever you want to think about it.
Okay, so when you do like second trace,
So if I was looking for the actual values of extrema, or actual values for the x-intercepts or the zeros, that's when I use that second trace menu. You're welcome. And I use the zeros command to find the x-intercepts, and I use the max and min commands to find the maximums or minimums, which would be the two types of extrema.
So for like number 1 or 2, you would do that?
Exactly, yes.
And then to access that, so it's the same steps as 5 through 8, you're plugging it into your calculator?
Yeah, so the graphing step is initially the same, right? So this one has no x-intercepts, right?
Yeah.
And it has one global maximum right at this point. So if I wanted to find that, I'd hit second trace and then use the maximum command. And then it wants a left bound and a right bound. So I'll pick some spot left of where I think that maximum is and to the right of it, and then guess in between. And there it tells me that I have a maximum. Okay. Reese. Yeah, so I just told you how to do the extrema just right here as an example. I didn't do number 1 or 2, I just did it with whatever I had in here. But you're just looking at the graph, and then you use second and trace. So if you want the x-intercepts or the zeros, use the zero command. If you want extrema, use the minimum command to find the minima, and use the maximum command to find the maxima. And all three of those functions work the same way. They ask for a left bound, right bound, and guess. So you just move your cursor somewhere to the left of where you think the thing is that you're looking for. Press enter. Move your cursor somewhere to the right of where it is. Press enter. And then the guess doesn't matter as long as you're picking someplace in between your two bounds. It's fine. I usually just use wherever I'm at and just press enter. Is that okay, Reese?
Yeah.
I didn't actually show it, but it's like kinda did.
No,
It's okay.
Yeah.
Aaron.
Sorry to repeat so much stuff, but
It's okay.
So I'm at trace. So then, what's the button for the finding the minimum maximum?
So you'll use, depends on which one you want. You'll use either the minimum command or the maximum
I'm
command.
asking where that is in the calculator.
Oh, so you hit graph, right? And then you press second, and then the trace button.
Oh, okay. Yeah, I found it. All right, then it gives me, okay, yeah, that makes sense.
You good?
Yeah.
Okay.
Yeah.
Sure.
This is just 1 through 8 type stuff on the homework for that?
Or stuff we did in section 1 in general. I mean, there's some like vocabulary-ish stuff. Yeah, like differentiating between like local minimum and global minimum and that kind of stuff.
Okay.
Stuff, again, that's review from last year.
Yeah.
That's just like kind of self-explanatory from the wording. Reese?
So if I'm like finding the, oh wait, no, never mind, I got it.
Okay. There, that's fine. Never mind then. Yeah, Aaron?
So for 3 or 4, would you just like, would you graph that and see how much extrema in zeros it has, or?
No, you can do that just by using a theorem.
Okay.
So all you need to do is look at the degree of the polynomial.
Yeah.
So for example, number 3 is degree 5. So that can have at most 5 zeros.
Okay.
And it can have at most 4 extrema.
Okay, so the extremas are 1 less than zeros.
Yep. Yep. And again, the word at most there is important, because really at most 5 means it could have 5 zeros, 4, 3, 2, 1, or no zeros, right?
Then how would you do like 5 through 8?
So I did 5 here just a moment ago. So again, since I noticed 5 through 8 are all polynomials, I know that they just have an arrow at the left end and an arrow at the right end. So like the left end is negative infinity and the right end is positive infinity. So I can just write this part right off the bat. I know that part's going to be there every single time for every polynomial function, which is what we're looking at. And then I'm just going to look at the graph. So I'm going to type that into my calculator and look at the graph. And since I look at the left arrow is pointing down, we just say that this is equal to negative infinity. And because the right arrow is also pointing down, I'd say that one is equal to negative infinity also.
Okay, so I'm just going for like where it goes on this side, where it goes on that side.
Yeah, you're just describing what the arrows at the end of the graph are doing.
So we're gonna if they're positive or negative.
Yeah.
Oh, okay, that's
Yeah. It's get it. The notation looks weird, but all you're doing is saying, when I look at this, this is saying the left arrow points down. This is saying the right arrow points down. That's all it's saying.
And I find that graph by just plugging that function into there.
Into the y equals menu, and
Yeah.
you might have to monkey with the window so you can see the ends of the graph appropriately, but like that's should be fairly straightforward. It is graphing. Lily.
So when we're doing like 1 and 2, we have to have 3 zeros, right?
No, you have at most
At most.
3 zeros.
Okay.
So there could be 3 zeros, could be 2 zeros, could be 1 zero, could be no zeros.
Okay, thank you.
So if you look at the graph, I think that one does have 3,
Yeah.
but it could have less,
Okay.
right?
And then do you just know how many zeros it is from the extremo? Or not the extremo, from
So if you're looking at the graph, the x-intercepts are the zeros.
Okay.
So you're just looking for where it's crossing.
thank you.
And you can usually see that right away by looking at your picture.
Yeah. Okay, thank you.
Okay.
I can't see it very well. So like for 5, like what does that say like for what I have to write? No, like what you wrote. Like do I just have to write f of x equals negative infinity, f of x equals negative infinity?
So the whole thing is the answer.
I can't really read what that says.
It says LIM,
Alright, so I put lim.
and then the x arrow, negative infinities underneath the LIM.
Yeah.
And then we have f of x equals.
Yeah, okay, that makes sense.
So this is saying the limit as x approaches negative infinity of f of x is equal to
Yeah.
negative infinity,
I got that.
is how you'd like read that as a statement. Okay. What's up, Reese? You got it, though? That's good. I'm glad. Okay. Any other questions here? Happy to deal with some more if anybody's got anything else. Yeah, Grace?
Is the homework quiz just like the first homework or was it like last time?
Is dealing only with section 13.1. I do want to make a point here. I think last time I asked you guys to do the homework was 9 through 18. We actually didn't do enough to talk about 13 and 14 yet. So you can skip those until we get a chance to do that. We will eventually do those, but the homework really should have been 9 through 12, and then 15 to 18. Or 19, excuse me. Did I write 13 up there, not 15? Reese, what's up? That's my plan. That being said, I would like to mention that some of us have not turned in a homework assignment all year, or have like many missing homework assignments. Yep. Well, at least this semester. I would love if you were able to, especially during the asynchronous days here, get a little something in. It would go a long way of, like getting yourselves caught up and getting your grade in a much better place and a much better chance of like going into the final with a, higher than 70% grade. As most of us did reasonably well on the final last year with the format that we used. So if you've been short on your homework assignments and missing a bunch of those, try to find some time here in the next week or so to catch up on something, right? Like, and if it's like, oh, it feels like it's a mountain, there's too much to do, just like, how do you move a mountain? You just do it one rock at a time. So just do something, doesn't matter what it is. Start with something that's the most accomplishable. That's like, hey, I know how to do this homework. I think I remember how to do this. This is not very long. Let me start here. Do something. Email me when you finish things, and I can go and re-enter them. Okay? Try not to wait and do it all at the last minute, because that really bothers Mr. Kulik. But every once in a while, if you're like, hey, I got some extra stuff done, or I got some old stuff done, can you check this? I might not get to it that day, but I'll get to it, and I'll send you a thumbs up back after I do it. I'm not mad about it. I'm a little annoyed that we're not doing anything, but if we can do something, that would be good.
It's gotta be seniors.
You'd be surprised. It's both grades. Okay. We feel okay about the homework here that we had talked about? Okay. Let's do a little bit more in section 13.2. And then we'll get going on this homework quiz here to finish up. Sound good? Great. Do you have to ask something here, guys?
Yeah, Reese does.
We're good.
Okay, I'd rather do the lecture and then end with the homework quiz,
Yeah.
if that was going to be your question,
That was Reese's.
because it's a little bit easier to just like, when you're done, then like we have to get everybody done and then restart. From a teacher standpoint, that's much easier for me. Okay. So last time we had talked about polynomial division, right? So for example, we would have something like 2x squared minus 5x plus 4 divided by x minus 2. So we take the divisor, that's the bottom of our fraction, put that on the outside of the division thingy. And we take the numerator, or dividend, that's the top of the fraction. We write that underneath the division thingy. And we ask ourselves, what times the leading coefficient of the divisor gives us the leading coefficient of the dividend. In this case, what would that be? What times x gives us 2x squared?
2x.
2x, right? So then I multiply that 2x to both parts of the divisor, the part outside the division thingy, and write the answer to that multiplication problem underneath. And then we're going to subtract down. Now, personally, I think it's easier not to think about this as a subtraction problem, but rather to think about it as an addition problem. So I'm going to distribute that negative through. So negative 2x squared plus a negative 2x squared, those cancel out. Negative 5x plus 4x gives me negative x, and then I bring the 4 down. And then I repeat. I say, okay, what times the leading coefficient of the divisor gives me the new leading coefficient of the dividend? How about negative 1? Right? So negative 1 times x gives me negative x. So I'll go ahead and multiply that negative 1 to the entire divisor. I'll write that underneath my current dividend and then subtract down. I don't like to think about this as a subtraction problem. One of the most common mistakes I see students make is goofing up the negative signs here. I think it's easier if you distribute that negative through and think about it as an addition problem. So that becomes plus x and plus a negative 2. So negative x plus x, those just cancel out. And then 4 plus negative 2 is 2. So that's my remainder, 2. So we'd say our answer then is the quotient, 2x minus 1, plus the remainder, 2, over the divisor, x minus 2. So we'd say that's what our answer should look like. Joe?
It's probably a dumb question, but why can't you, instead of using a negative 1 in the division process, you just use a regular 1? Because wouldn't it give you x, and the negative x and x cancel out?
Because I have to subtract down.
With the 4 and
So,
the 2, you mean?
No, because if I had just this and then I subtracted down, x minus negative x minus x is negative 2x. They don't cancel out.
Okay, I see what you mean. That makes sense.
Again, we're trying to cancel that leading term every time, is the goal there. Is that okay with everybody? Okay. So, polynomial division. This is kind of how it works. We did this last year. We've reviewed it a couple of times. We did one yesterday. We've done one today. We'll probably do one next time. Should be a technique that you guys feel comfortable doing. You'll need to do it in the homework, so you get a little bit of practice there as well. This polynomial division, though, has 2 uses. The second use is called the factor remainder theorem. And it says that if a polynomial f of x is divided by a monic polynomial, so that's something of the form x minus k, where just k is some number. But the key here is that the polynomial you're dividing by has to be degree 1 with leading coefficient 1. That's the key here. Yes, Reese? Remainder? That's okay. So what this is saying in our case is that the remainder we get should be the same thing as if we plugged the thing in. So if we go back to our previous example here that we did, notice that this, our divisor, is in that form where the leading coefficient is 1 and the degree is 1. So what this is saying is that if I did f of 2, where my f of x is 2x squared minus 5x plus 4, this should, f of 2 should equal 2, which is my remainder. Let's just verify that. So 2 times 2 is 4, and then times 2 again is 8. 5 times 2 is 10. 8 minus 10 is negative 2. And plus 4 is 2. Right? And why is this 2 here? I guess we should have led with that probably. Okay, well that's fine. The place that we're interested in, though, is like the factor piece of this factor remainder theorem. So the first part just says if a polynomial f of x is divided by some monic polynomial, then the remainder is the same as substituting. This says that a polynomial f of x has a factor of x minus k if and only if f of k is equal to 0. So what is this really saying here? Well, let's translate it into numbers because it's a little bit easier to see what it's saying here. So if I say, is 2 a factor of 6? What would you answer to that? Yes. Why? Because if I do 6 divided by 2, I get 3 with 0 remainder to it, correct? Would I say, if I asked you the question, is 2 a factor of 7, you would say no, because when I divide 7 by 2, I get a remainder. That's what we're saying here. So I can say that x minus k is a factor of f of x only if the remainder, which is the same as f of k, is 0. So let's look at an example where we can kind of apply this. So one way I can do this is I can use polynomial division to show that I get a remainder of 0. So let's go ahead and do that polynomial division. So I'm going to ask what times the leading coefficient of my divisor gives me the leading coefficient of my dividend. 6x squared. I'll then multiply that to the entire divisor. And then subtract down. Remember, I like to distribute the negative and think about it as addition problem. So I'm going to be adding negative 6x cubed and then adding negative 18x. 6x cubed plus a negative 6x cubed is 0. 25x squared plus negative 18x squared is 17x squared. And then we'll bring the next piece down. And then ask ourselves what times the leading coefficient of the divisor gives us the new leading term of the dividend. I would say 7x. And then we distribute through, so I have 7x squared plus 21x. And then we subtract down. And again, I like to think about adding negative, so I'm going to distribute through the negative. (7x squared plus a negative 7x squared is nothing. 16x plus negative 21x is negative 5x. We'll bring that last part down. And then I'll ask ourselves what times the leading coefficient of our dividend, or I'm sorry, divisor, gives us the new leading term in our dividend. Negative 5. That's right. So I'll multiply that to the entire divisor. And then we'll subtract down. Again, I'm going to distribute the negative. So it becomes positive 5x and positive 15x. I add down both times and I get remainder 0. So I can say that since x cubed plus 25x squared plus 16x minus 15 divided by x plus 3 is equal to 2x squared plus 7x minus 5. I know that 6x cubed plus 25x squared plus 16x minus 15 is equal to 6x squared plus 7x minus 5 times x plus 3. i.e., we were able to factor that. Just like when I asked you, is 2 a factor of 6? One of you guys said yes, because 2 times 3 is 6. That's essentially what we've done here, right? Instead of writing it, oh yes, I know 6 or 2 is a factor of 6 because 6 divided by 2 is 3. Alternatively, equivalently, the statement that's saying 6 is 2 times 3 is the same statement, right? Joe?
So in this example, we had no remainder. So if there was a remainder, then
they're not factors.
okay.
Then you can't say that that's a factor.
So what would you write? Just like not no factor?
You'd say it's not a factor.
Okay.
But if it's a question like show this is a factor,
Yeah.
then
More times than not.
no, it means that is the answer. You know it's going to work.
Oh, okay.
Like it means that you made an arithmetic mistake probably somewhere along the way. Or else the problem is just there's a flaw, like your teacher made a problem that just doesn't work. Yeah, there's a typo or something. Okay. Now that's kind of a hassle, right? What's the other way of doing this? Well, if I use the factor remainder theorem and I think of my f of x as this and my x minus k as x plus 3, then I can just do f of k and try to show that that's equal to 0. In this case, what does k have to be? I know x minus k is x plus 3, so k has to be negative 3. Is everybody okay with that? Oh, we're going to need the calculator at some point here. That's negative 48. I guess I don't need it there yet, but I'm gonna. I just don't want to do 6 times 27. What's that, 162 maybe? Yeah. I just don't trust myself at this time of the day. Okay. Oh, 25 times 9. I'm so dumb. That's 25. I did 25 times 7. There we go. Okay. 162, or negative 162 and 225 is 63. Negative 48 minus 15 is 63. So that's 0. So I can say, since f of negative 3 is equal to 0, that means that f of x divided by x plus 3 has remainder 0. So x plus 3 is a factor of f of x, So this way was a little bit easier, right? I didn't have to do the long division. All I had to do was like type this into my calculator, and realistically, this piece here, I could have just typed into my calculator as one line and pressed enter and gotten 0, right? I did it by hand to just illustrate what was going on, but like that was much easier. Everybody agree with that? What's the downside though? If I compare these two methods, the second method was easier, but what don't I get? I don't actually get how it factors, right? Yes, I know that it works, that it is like that is a factor, but how the heck would I find the other factor? We don't have that. What we want to be able to do is combine these two methods where I can do the substitution but still also recover the other factor. We did this last year. Does anybody remember what we used to do this? We called it synthetic division. And it's super, super, super critical that you're able to do synthetic division, because realistically, everything we do after this point in this chapter is going to be using synthetic division. So if you cannot do this process, woof, it makes the rest of the chapter like kind of not much you can do with it. So you really do need to get good at this process and be able to do it quickly and accurately. So as far as this chapter goes, at this point, if you don't have this particular skill, not a lot you're going to be able to get right from there on out. Okay? All right. So the synthetic division setup starts with like a bar that looks like this. This piece tells us what number goes out here, which is going to be the value for k, which in this case we saw was -3. I'll put that there. Does that look familiar to everybody? And then what goes inside are the coefficients for my f of x. Does anybody remember what we have to be careful about on this setup step? Grace? Yeah, so if your f of x skips a term, like if you go from x cubes to x's and you skip the x squareds, what do we have to make sure we include? A 0. If you do not do that, everything will be wrong. It is critically important that you're including zeros if you're skipping a term. Okay? We'll see an example of that later, but I wanted to make mention of it now because I think this will be the only example that I do here because I want to make sure that we have enough time for the homework quiz. Okay, so this is the start. We've set it up. Now we're going to do the synthetic division. The first step is I'm just going to take that very first coefficient and write it down underneath my bar. Easy first step. What I do next is I'm going to multiply the -3 by the number underneath the bar that's furthest to the right and write that answer in the next spot and then add down. Is everybody okay? And now I'm just going to repeat that process until all of the spots underneath the coefficients of f of x have been filled. So we'll do -3 times 7 now. It's -21. We add down, that's -5. Multiply the -5 by -3. That's 15. Add down that 0. That's what we're hoping to get. So again, the last piece there is telling you the remainder from the division problem. The rest of this, though, is giving us the quotient. So counting back from the 0, this is the constant term, is the next one. That's the coefficient on the x. The next would be the coefficient on the x squared, and so on. We're just counting back from the remainder. The next term is the constant, that's 0 degree. The next piece is the linear term, that's degree 1, degree 2, degree 3, and just we keep counting back as long as we have numbers. So what this is all telling me is that 6x cubed plus 25x squared plus 16x minus 15 divided by x plus 3 is equal to 6x squared plus 7x minus 5, remainder 0, so I don't need to write anything there. Or if I write this in factored form, 6x squared plus 7x minus 5 times x plus 3, which is the same thing that we got from the polynomial long division. Now, this synthetic division process is quite a bit quicker, particularly if the polynomials get quite large, which they can. This is a pretty nice, quick process. Yes. Oh, that should be 5, sorry. Yeah, sorry. Yeah, thank you for asking. Again, if you don't understand what something is and it's like, did you write that number down wrong? It's very possible I did. Mr. Kulik makes mistakes. Tries hard not to, but it's 8:40 in the morning and he got feels like he about 3.5 hours of sleep last night because he can't manage to stay asleep anymore. It's becoming a problem. So to say I'm operating less than full capacity would be an understatement. Anyways, does this look familiar? You guys remember doing this last year? Hopefully. Okay. We're going to stop here. As far as the homework set goes, you guys should be able to do now 20 through 23. Yes, 13 and 14, we have not addressed how to do that yet. We will. In fact, let's just do that right now. It'll be relatively easy. Okay? Let's do that. You know what? I'm glad you did ask.
Are you sure we can't just leave it at that and have
Yeah.
our homework list?
Look, it's going to take literally 2 minutes to do this. Okay?
Teaching us how to do this. Oh, yeah.
So factor remainder theorem in reverse. So let's say we want a polynomial with the zeros 2, 3, and -5. So what we want is f of 2 should equal 0, f of 3 should equal 0, and f of -5 should equal 0. Right? What that means then is x minus 2 has to be a factor. X minus 3 has to be a factor. And x plus 5 has to be a factor. So my polynomial then should be like that. And if you wanted to FOIL those out, that would be fine. If I look at the answer key, that is what the expectation was, is that they factored, is that you FOILed that out. But that's the gist of it. Oh, you should FOIL it out, but that's the idea. That's it. Fairly straightforward, right? So this would be the 13 and 14. And then we still want to be able to do 20 to 23. Yes, let's all blame Grace. Blame Grace for making sure you get a thorough education. Okay.